Ladies and gentlemen, good morning. My name is Ajala Peter. Today we are discussing polynomial. 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 And lest I forget, in our last master's, in the video, choreographic equation, I gave a question. I said, factorize x squared minus 7. Now there are things to check out here. You'll be like, how will I factorize this? This is a perfect square, but this is not a perfect square. Now, since this is not a perfect square, you can make it a perfect square. You can make a perfect square out of it. You can change it into a perfect square. Not by putting square, because adding square makes it 49. But by finding a perfect square that is still equal to 7. And how do we go about that? Now, this is it. You can check more of it out even if you feel like you want an in-depth knowledge about concept of powers. You can check my videos, concept of powers. And there you find difference of two cubes, difference of two squares, difference of two fourth powers, perfect squares, perfect cubes, everything about powers are discussed over there. So you can just check it. And mind, after this video, don't forget to subscribe if you haven't done that now. Remember to subscribe, press the bell button in order to be notified whenever a new video is released. So, solving this. Now, mathematics taught us a squared minus b squared. As you can see, this is the difference of two squares. Why? This is the perfect square, this is the perfect square. What's in between difference? Talking about difference of two squares. We still have sum of two squares. It says this thing is equal to a plus b, minus b. We can prove it out. Now let's open that bracket. If we have a plus b, then a minus b. Let's open the bracket. Are we having a times everything here, right? A minus b plus b into bracket everything here. A minus b. So that's a times a squared. A times minus b minus ab. My plus b times a plus ab. Plus b times minus b squared. Minus ab plus ab is what? They cut out each other. What's left? A squared minus b squared. That's the difference of two squares. So meaning for us to solve this, definitely this thing will be equal to something like this. Two brackets as usual. X plus something and x minus something. And that something is the perfect square of this. Now, you'll be thinking this thing, as limit is 4, we can say okay, x squared minus 2 squared. It has become a perfect square. Assuming it is 9, this one, assuming it is 9, we can say x squared minus 3 squared. Assuming it is 16, we can say x squared minus 4 squared. But as it is now 7, what can we do? What is equal to 7? Now, how about saying root 7 squared? Is it not equal to 7? It is. And also a perfect square. Is it right? So you can just deduce that by saying, okay, x squared minus 7 is equal to x squared minus root 7 squared. Right? X squared minus root 7 squared since root 7 squared is equal to 7. You substituted it. And now we now have two squares. So you can now apply it. Two brackets, then x plus what was there, root 7, and x minus root 7. That's the solution. Quite easily done. So that's just it. So, and if you feel like you need more knowledge about difference of two squares, two cubes, fourth powers, sum of two cubes, and so on, you can check the video concepts of powers. Thank you very much. Now let's go into today's class. Today's class we shall be dealing with polynomial. Now polynomial, we did quadratic, and quadratic can be defined as quadratic expression can be defined as the product of two simple linear expressions. Polynomial is also probably the product of 3 or more Or let me assume two or more questions. Can find as two or more simple linear expression, because when we're talking about polynomials, we are talking of, let's say, we're talking about polynomials, let's say we're talking of 1, 2, 3, and so on. You don't understand me. You know, quadratic, we're only talking about 2, right? But polynomial, we're talking about 3 and so on. It can be 4, it can be 5, it can be 6, and so on like that. But do you know, if quadratic equation is ax squared plus bx plus c, this is a quadratic expression, right? This is a quadratic expression which has the highest power of what? 2. Now, polynomial. Polynomial is also ax, now having 3, additional 3, plus bx squared plus cx plus d. Another polynomial is still ax raised to power 4 plus bx cubed plus cs squared plus dx plus e. Another polynomial is still ax raised to power 5 plus bx raised to power 4 plus cs raised to power 3 plus dx squared plus ex plus f. All these others are polynomials. They are all what? Polynomials. But this is the polynomial of the power of 3, the polynomial of the power of 4, the polynomial of the power of 5. But should I now tell you something that is controversial? No. Do you know this is also a polynomial? We can also regard this as a polynomial. So I can give a saying that says what? All quadratic equations are polynomials. But not all quadratic expressions are polynomial. But not all polynomial are quadratic expression. As this is a quadratic expression, it is also a polynomial. But only if we have this type of polynomial, then it is a quadratic expression. But once we have all this type of polynomial, it is not a quadratic expression. So I can as well say that all quadratic expressions are polynomials, but not all polynomial are quadratic expression. I think that part is clear. Now all this thing has names. Now if it has power of kids, it's also known as cubic expression. You know, cubic expression. If it is this one is otherwise known as quartic expression. Quartic. This is otherwise known as quintic. Everything like that and so on. Everything has what they carry. They have their names and everything. I think that's clear about polynomials. Now the highest power in the polynomial determines the number of factors it has. So the reason why this quadratic expression only have 2 factors, you get it, is because the highest power there is 2. If this one will be having 3 factors, this will be having 4 factors, this will be having 5 factors. But one thing about polynomials is that they always have at least one simple linear. Even if you want to, there's no way you will factorize it. You always have at least. Okay, you don't want to, at least simple linear expression must be there. So that's that about that. That's that about that. Okay, so let's step up. Now, when we deal with polynomial, there are some arithmetic. I mean addition, subtraction, multiplication, division. Division of polynomial. Division of polynomial. And division of polynomial. And division of polynomial. Okay. Now, another thing is this. Now, when we're doing polynomial, there are sometimes, for instance, if we are given 24 x raised to the power 4 plus 32 s cubed minus 5s squared plus 7s minus 51 equals to 0. If you are given this, then I said, okay, if x is equal to 17, evaluate this. Then guess what? If x is equal to 17, find the remainder. You'll be like, 24, 17 raised to power 4, and they don't tell you, okay, without the use of calculator, do this. How do you think you will go about it? without the use of what? Calculator. So there's no way you use calculator, fine. But still, when you have massive numbers like this, there's something we call the nested form. Nesting of equations. Yes, nesting of equations. We nest equations. They say when we talk about nesting, we talk about grouping, grouping. Now you pick the first, this one thing, you pick every coefficient with a single unknown variable. So as I have 4 unknown variables, that's x raised to the power 4, x times x times x times x. I only pick one of them. And you pick it as a linear, simple linear equations. For instance, let's do with this. Here I have 24x for you like this. 24x raised to the power 4 plus this. Now you pick with the power of 1 first. So 24x plus, what's the coefficient of this? 32 in brackets. 1x is outside. What's the next thing? Minus 5. 1x is outside. What's the next one? Plus 7. 1x is outside. You keep bracketing it. Now what's 1x is outside? What's next? Minus 51. This is the nested form of this equation. If I should unlock this bracket, I'll still get this back. Let me explain with a simpler equation. I'm not sure you understand what I'm doing, but let me explain with a simpler equation. Let me find one simpler. Okay, let me just guess one. Okay, 2x raised to the power 4. Okay, better still, let me use 3. 3 plus s squared minus 7 s plus 3. I have this. And now it's okay, Peter. If x is equal to 7, find the remainder. It's very easy. How do I do this? Okay, instead of me doing, I can do it in 2 ways. Anywhere I see s, I put 7, right? I can do like this: 7 cubed plus 7 squared, right? Minus 7 times 7, right? Plus 3, isn't it? So now 7 times 7 times 7 is equal to what? 14. That's 7 raised to the power 3, right? I'll have to react my brain for all this one for 9, 49. Everything. Instead of that, I can just pass a faster route. What's the faster route? Now if I should have this 2x cubed plus x squared minus 7x plus 3, I can use the nested formula. Now the coefficient of this thing is 1, right? Forget about the powers, just continue. What do I have here? 2x, you put the coefficient, you put an x outside, except if it doesn't have an x. If it doesn't have an x, just transfer it here. Sum it up with the coefficient. Sometimes it's scatter it and tell you to find the nested form. Okay, though it's just a short, so it doesn't come out like that. X, then what's next? Minus 7, right? Put it in bracket. What's x is still here, right? Plus 3. I'm through with the next thing of this. Now you find out I group this thing into linear equations, simple linear ones. 2x plus 1. What is it? Is it a simple linear expression? Yes. X minus 7, is it? Yes. X plus 3, is it? Yes. Now if I'm asked to input 7, it's very easy. I cannot say, okay, 2 times 7 plus 1, 7 minus 7. You must just be careful because of odd mass. Then 7 plus 3. You start with the numbers bracket. 2 times 7, 14, right? Plus 1, right? 7 minus 7, 7 plus 3. You don't touch anything. You allow it from inside. Now, 14 plus 1 is what? 15. 15 times 7 minus 7, 7 plus 3. Now, 15 times 7 is equal to what? 5. 15 times 7 is what? 5, 3, 105, right? 105 minus 7 is in the bracket now. 7 plus 3, right? 105 minus 7 is equal to what? 98, right? Times 7 plus 3. 98 times 7 is equal to what? 98 times 7, okay? 686 plus 3, right? Now 686 plus 3 is equal to 689. I can at least get my answer without the calculator. But trying this now, I have to be okay with 7 times 7, 49. 49 times 7 is equal to what? So that's 3, 6, 7 times 4, 28 plus 6 is equal to 24, 32. Like that. Plus 49 again. Minus 49. Plus 49. Okay, minus 49 is guessed out already. Then I have, what's it called? You can't try to say here. So that's just the concept about that. That is the concept about nesting. The concept about nesting. Now let's move into the business of polynomial. Now we have addition of polynomial, subtraction of polynomial, multiplication of polynomial, and division of polynomial. And division of polynomial. And division of polynomial. Now let's start with addition. Addition of polynomial. You can be given, okay, P. Okay, I can say P of x is equal to 3s cubed, right? Plus 2s squared minus s plus 2. Then I cannot tell you g of x is equal to 4s cubed plus x minus 2. Minus 2. Then I'll tell you h of x is equal to s cubed plus 3s squared minus 5. I'm given this. I'm now asked to find p of x plus g of x. This is first thing I'm asked to find. Then b, I'm asked to find p of x minus h of x. Then c, I'm asked to find g of x times h of x. Now addition. Now hello. I want to, okay, let me just use this to explain addition, subtraction, and multiplication. Yes, I would like you to be attentive, okay? Okay, now let's start. A. What's my p of s? My p of s is 3s cubed plus 2s squared minus x plus 2. This is my p of s. Now, plus, what's my g of x? 4s cubed plus x minus 2. Now, if you are very observant, you find out there is no power of 2 in this equation, isn't it? I'll explain it. That simply means it is equal to, let me write 3s cubed plus 2s squared minus x plus 2 plus 4x cubed. What can be here that will be equal to? That will be equal to 0. 0 plus anything is still that thing. So if I say 4s cubed plus 0 is still that thing, right? So I can as well say, okay, maybe it is plus 0x squared. So 0 times x squared is still 0, which is making it blank, right? Then plus x minus 2. So I'll advise you to put 0x squared wherever you find out your variable there, or whatever is supposed to fill it is empty. Just with 0x the power you want there. So it is not in the descending order again. I think that is clear. Now, the way I will solve this thing, I'll solve it in 2 ways. I'll solve the first one. It's very simple. In fact, I will solve it using thousands, hundred units, and tens. Tens and units rather. Okay, now let's start. Let's bring it. So, what's the first thing we have? We always have thousands. we have hundreds, tens, and units, right? Now, anything with the power of unit. Why do I use thousand to unit? Because I have four variables: 1, 2, 3, 4. 1, 2, 3, 4. So assuming there are just three, I'll be using 100 tens units. Assuming there are just two, I'll be using tens and units alone, right? Okay, fine. Now, the power of 3, let's apply now. I'll be here, the first line I'll be putting P of S, the second one I'll be putting G of S. Mind you, we are dealing with addition. Are we good to go? I'm breaking it down as possible, as simple as possible. Okay. Now, what do I have as my PS? 3s squared is the first one. 3s cube, brother. 3s cube. What's the 100? 2s squared. This plus 2s squared, right? The next one is minus x. The next one is now was plus 2. The sign goes with whatever it is, right? And this minus x will be minus 1x. The sign goes with the variable itself. Here I have positive 3s cubed. Okay, now for this I have positive 4s cubed. Positive 4s cubed. Next one, positive 0s squared. Next one, positive 1s, right? Next one, negative 2. Now let's start. Your addition starts from the back, right? Fine. Plus 2 plus minus 2. You will do plus times minus, Abi, which is minus, isn't it? Now, plus 2 minus 2 is what? 0. It's out of the game. It's positive 0, right? Moving on. Plus times plus is still plus. Minus 1s plus 1s is still what? Plus 0s. Also out of the game, right? Okay. Moving on. Plus times plus is plus. Plus 2s squared plus 0s squared is what? Plus 2. Sorry, let me minimize the size of this. 0s plus 2s squared. Let's move to the next one. Now, plus times plus is still plus. 3s cubed plus 4s cubed is what? Plus 7s cubed. You can no answer. So just say, therefore, P of s plus G is equal to, then write this out. 7s cubed plus 2s squared. These are zeros, therefore useless. That's the final answer. That is the final answer. But there is one exception to this. Now, when we're in basic class, then we were told if we should sum two numbers and we have a number that is a tenth, in the sense that maybe like I have 10 downward. So if I say 2 plus 2 is 4, I can write it as a unit, right? But if I say maybe like 5 plus 9, what would I guess? I'll be guessing 14, right? Good. Now they will ask us to write 4 and carry 1, isn't it? But in this case, you write the whole 14. You are not carrying anything. You write as the what? The whole 14. You write as the 14. You don't carry anything. That is the difference. But still the same application. To avoid confusion. I hope this is very clear. Okay, now let's move on. This is the first method of solving it. This is the first method. And the second method of solving. So let me just write it here. Method 1. Now, the method 2, let me explain it here. Now, the second method is this. As this is, you will remove the bracket. Let's do the bottomless. We will open what? The bracket. Now let's start. We start, so 3s cubed plus 2s squared minus x plus 2. Plus times plus 4s is still what? Plus 4s cubed, right? Plus times plus 0s is still plus what? 0s squared, right? Plus times plus s is still plus s. Plus times minus 2 is still minus 2. I hope you understand. Now we collect like terms. We bring the ones that have same powers together, the ones that have different powers together. Okay? Sorry, same powers together. So 3s cubed. Do you have any other s cubed? Yes. I have 4s cubed. I bring them together. 3s cubed. Z plus, yes, plus 4s cubed. or better still, let me bring them together first. Okay, what I move to s squared. Do I have another s squared? Yes. 2s squared plus 0s squared plus 2s squared plus 0x squared. Next one, I have negative x plus x. The next one plus 2 minus 2 plus 2 minus 2. Now to bring them into families. Now this s cube and s cube is their surname. For instance, if I should meet I am Ajala Peter, then maybe my brother is Ajala Paul. Are you getting it? Okay, now so if we are together, I am Peter is Paul. You get it? But if we want to classify it as a family, we are one. Same surname Ajala. So now same thing we'll be doing here. Now they have the same surname, s cube, s cube. But their names are different. 3 here, 4, that's their coefficient. So we can now say, okay, Peter and Paul plus 3, this plus 3 here, plus 4, come together as one family, Ajala, S cube. As one family, bracket. I don't know if I'm making any sense. Let me re-explain the concept. I don't know if I'm making any sense. Okay, now this is Peter Ajala, this is Paul Ajala. I get sense. Okay, here this is Peter Ajala 3s squared s cube. Paul Ajala is 4s cube. Now they can now come to exist as one family. Peter plus Paul representing Ajala family. Same thing applies to this place. Plus Peter Paul 2 plus 0. Same surname, s squared, s squared. Next one, plus. Here I have, here Peter is minus 1 and Paul is plus 1, right? Minus 1 plus 1, same surname, x. And here, no, is still 2 minus 2. I don't know how I've done that. Okay, now let's do a normal arithmetic here. 3 plus 4, 7 times s cube, 7s cube, right? Plus 2 plus 0, 2 times s squared, 2s squared. Plus minus 1 plus 1, 0 already. 0 times s is still 0. Plus 2 minus 2 is still 0. So finally, this is equal to 7s cube plus 2s cube plus 0 plus 0 is still the same thing. 7s cube plus 2x squared. Now let's check our answers here and here. Are they equal? 7s cube plus 2s squared. 7s cube plus 2s squared. Those are the two methods. So anyone you feel you understand best, though both are very explanatory, both are easy. It just depends on your choice. So that's that about addition of what? Polynomials.